Okay, so today we're going to learn how to write an equation if this thing might not be linear. So we have this chart over here, and sometimes these charts can follow different models. Like this could make a line, like we had yesterday. It could make some kind of quadratic function or some kind of U shape like this. Whoops. Or it could make an exponential function, which kind of starts out slow and then gradually increases very quickly. So we want to figure out which of the different functions we would want for this chart over here. So the first thing we're going to do again is we're going to put this in our calculator, since I don't want to graph this by hand. So I'm going to go and I'm going to put this in my calculator. And we're going to clear the lists so that we have a fresh start. But we're going to plug this information in, so 0, 2, 4, 6, 8, 10, 12, 16. And we'll plug it in the other side, 25, 36, 52, 68, 85, 104, 142, and 260. So now I've got both things in my chart. And today we're going to look at this graph a little bit better. So here's what I would like you to do. You're going to want to hit second stat plot, and you're going to want to go to this first stat plot, and it's like has an on and off button, and you're going to want to hit on. And then we're going to go to the zoom button, and there's a zoom stat button. So this is the only time you're going to use the zoom button. It is actually, like the zoom button a lot of times is not very good, but it is very good to find your statistical chart. So we're going to hit zoom stat. And then we're going to graph it. And it looks like I already have a line equation in here. But then we're just going to look at this graph. And this graph, it's kind of hard to see what would make this fit the best. Like it kind of looks linear, but it starts to kind of increase a little bit quickly. So maybe it's exponential, maybe it's quadratic, maybe it's linear. I don't know what would be the best fit. So we're going to take some stabs at this. So the first thing you're going to want to do is, now that you have an idea of what this looks like, we can't really narrow it down very easily, so we're going to hit the stat button, and we're going to go to calculate, and we're going to calculate a linear regression just like we did yesterday. And so our linear regression, and for today, let's round everything to the nearest tenth or whole number. So I'm going to say, well, this looks like it's y equals 13 minus 0.7. So we're going to say y equals 13x minus 0.7. That's our line equation. And now I'm going to go back to the calculator, and I'm going to actually plug that into my graph. And then I'm going to hit graph. And as we can see, that line actually looks like it hits the data pretty well. We got some data points that it hits well here. It's pretty close to all these. But this one is starting to get a little bit further away from. So even though this looks like it's a pretty good approximation, maybe it's not the best graph. So let's try our quadratic model. So I'm going to get rid of my line model. And now when I go to stat and calculate, instead of doing a linear reg, I'm going to do a quadratic reg. I'm going to hit enter. Again, we'll round all these. So that's like 1a. That looks like negative 1x. And that looks like a 33. So we'll just write that down. Y equals 1x squared minus 1x plus 33. So there's our quadratic equation. And again, we will plug that in for our y equals and kind of look what this would look like. So 1x squared minus 1x plus 33. We're going to hit graph again. And that one looks pretty good. As you see this, it goes through a lot of these dots. It hits this dot. It does miss these two dots. So this one is, I think, stronger than this next one, so we're going to get rid of this. So it definitely doesn't look as linear. This one looks a little bit better, but let's check the exponential one. So again, we're going to go to our y equals, We're going to clear that out. We're going to go to Stat, and then we're going to go to Calculate, and we're going to go to Exponential Reg. We're going to hit Enter. And so this one we can see is y equals a times b to the x. So when you write this one down, you'd write this as y equals 27 times, let's do 1.2 for that, just so we don't use 1. We could do 1 to the x. So this would be y, whoops, I don't want to use green for this. I want to use the same color. So we'll have y equals 27 times 1.2 to the x. So we just rounded that to the nearest tenth. And then let's just graph this thing. So we'll say y equals, plug that in. And hit graph. So far so good. It looks like it's going through all of them, and that one looks like it increases too quickly. So it misses a lot of these points. It's not as on track. We could change this. Let's do the 1.5. See if that's actually better if we didn't round. But it doesn't look like it's as nice. That one actually looks really good. There we go. I guess if I didn't round it, it's really, really good. So that is actually the best one. And that's like this, this type of graph is actually more, has more issues when you round it. So I guess we should have kept this to the nearest 100th, because it does affect it quite a bit. But we can see that this one actually hits every single dot. So this is our winner, and that one also isn't as nice as this one. So when you do today's thing, what you're going to want to do is, again, plug all your data points into the two lists. After you've plugged them into the two lists, you're going to go to second stat plot. Make sure this first stat plot is on. Then what you're going to want to do is zoom, go to stat, and then you'll have that graphed, and then you'll just start changing all those y equals to the different equations that you've gotten and see which one is the best. On the quiz on Friday, I'll probably give you a chart like this, say linear question mark, quadratic question mark, exponential question mark, and you'll have to give me all the equations, and then you'll have to tell me which one is the best based on what you saw. So just make sure that you can do this and plug it all in. The nice part is our calculator does a really good job of plotting these things for us, and it does a really good job of making these line equations.